is the second lecture of locomotion and movement. And in the first lecture, we have studied about the filament. That is of two types, thick filament and thin filament. But today's topic, that is the regulatory protein of that myofilaments. Okay, and in that regulatory proteins, first protein, that is the tropomyosin protein. Okay, and what is the tropomyosin protein comes here and no good way. That one tropomyosin protein becomes nearly similar size to one globular actin. Okay, one tropomyosin protein, that size is similar to one globular actin. Okay, and many tropomyosin, one tropomyosin size is similar to one globular actin, and many tropomyosin accompanies many tropomyosin polymerase accompanies together to form tropomyosin rod. Okay, and such two rods present in group of thick filaments. Tropomyosin, one tropomyosin becomes similar to one globular actin. Okay, many tropomyosin accompanies together to form tropomyosin rod. Okay, tropomyosin rod, such like this. This is the one tropomyosin, second tropomyosin, third tropomyosin, fourth tropomyosin, and many tropomyosin together form a comply together and form tropomyosin rod. Okay, and this tropomyosin size is similar to globular actin protein. Okay, many tropomyosin accompanies polymerase together to form tropomyosin rod. Okay, form tropomyosin rod, and such two rods present in group of thick filaments. Okay, next, that is the a tropomyosin rod or tropomyosin rod, such as this. This is the one tropomyosin rod. Okay, one tropomyosin rod becomes similar to one filamentous actin, because filamentous filament, that is also made by many globular protein. Okay, and here many tropomyosin accompanies together then form one tropomyosin rod. Okay, one tropomyosin rod forms by accumulation of many tropomyosin protein. Okay, so one tropomyosin rod becomes similar to one filamentous actin. Okay, and one tropomyosin protein, that is similar to one globular protein. One tropomyosin becomes nearly similar to size of one globular, okay, actin. Okay. Next, this is the figures of tropomyosin rod. Okay, next, protein, that is the troponin protein. You never forget that troponin protein that is formed by three polypeptide chains or three unit, that is TPT, okay, TPI and TPC. Here it is very necessary to understand that what is TPT, TPI and TPC. If you don't know, then know here that TP, this TP, that stands for troponin. TP stands for troponin and this T stands for tropomyosin. This means troponin, tropomyosin. TP with troponin, I stands for inhibitor. This means troponin inhibitor, and this with TP and C. So TP that stands for troponin and C stands for calcium. Okay, this means troponin calcium. Okay, troponin protein that is formed by three polypeptide chains, that is TPT, TPI or TPC. Okay, what is the role of TPT? TPT, this means troponin tropomyosin. What is the role of troponin tropomyosin? Then troponin tropomyosin that bind with tropomyosin. Okay, troponin tropomyosin that is bind with tropomyosin. What is the role of troponin inhibitor? Troponin inhibitor. From the inhibit word, you can understand this role of inhibit or what inhibit. You can see here that's troponin inhibitor that hide myosin binding site. Hide myosin binding site, thus inhibit muscle contraction. Okay. TPI, that stands for troponin inhibitor that hide myosin binding site. Okay, thus inhibit muscle contraction. Okay, what is the role of third TPC? That stands for troponin calcium. This means TPC for binding with calcium. TPC stands for troponin calcium, that stands for binding with calcium. Okay, to understand good way all lectures, you can see these figures. Okay, which is present on the whiteboards. This is the TPT and TPI or third is TPC. Okay, here you can see here that this is the troponin, tropomyosin. Okay, tropomyosin that denoted by TP. Okay, tropomyosin, and this is the TPT, troponin tropomyosin, TPI troponin inhibitor, and TPC troponin calcium. This all is called troponin, and this is the myosin binding site that is hidden. Okay, myosin binding site that is hidden. Okay, and this part is called the glomerular active part. When calcium calcium ion binds with TPC, Here, myosin binding site is hidden. Okay, but at that time, when calcium ion bind with TPC, after binding of calcium ions with TPC, what happened? Then myosin binding site exposed. Before, when calcium ion is not binded with TPC at that time, myosin binding site is inhibited, is hidden, is hidden. But when calcium ion binds with TPC, after that, myosin binding site is exposed. Can see here that myosin binding site after the binding of calcium ion with TPC, myosin binding site is exposed. Okay, okay. When myosin binding site is exposed, then muscle contraction can happen. How? Because myosin binding site is now exposed, and in then when myosin binding site is exposed, then ATP binding site, hydrolysis of ATP is happen. After that, muscle contraction is happen. Okay, where ATP hydrolysis happen? To add the head part, hydrolysis of ATP happen in head part of myosin. Then muscle contraction happen. And when ATP binds with myosin head part, then muscle relaxation happen. Okay? Thank you.